Okay, so hello, this is Klaus Fischer speaking. I'm at the German Research Center for Artificial Intelligence in Saarbrücken in Germany. And here I'm head of the Mighty Agent System Group in the Department of Agents and Simulated Reality. I'm going to explain some work that we did on what we call DyVisual, which is meant to do dynamic visualization and interaction in the context of Fitman. So please, if I go too fast or if things are unclear, just interrupt me and I'll try to clarify things as soon as they come up. So just as a brief overview of what I'm planning to do is I give a bit of background for people who might not know anything about what they are going to see. Then I will explain DyVisual, its basic features and the basic technologies, and go to some use cases. Two of them are done in the Fitman context, and then I've got some extending examples which show actually what we also do outside of Fitman, which goes beyond what we actually could do for Fitman. So to start with, I just show the kind of work that we do in our group or in our department. It's mainly, do you also see my cursor, Stephen? Is this visible, the cursor?
Yes, I can see it.
Okay, great. So one major part of the group is working purely on graphics, meaning visualization, a large model of these. Then I already said I'm head of the multi-agent system group, so we do agent-based systems. We did applications in this area, but the combination of the two, the agent technologies and the visualization is of course of a core interest in the group, and you will see later on examples of that. So where does this all come from? So the World Wide Web out there did over the last years change dramatically from a pure text-based, let's say, environment where you could look at text and read it and jump from one text to the other to a multimedia platform where you can have different content within one page, like audio, video, whatever, and build applications on that, which you can access from your home and use them. So the basic technology that makes this possible, of course, is HTML5, and it integrates graphics, vector graphics, audio and video and text into a uniform manner that you can actually visualize it with a browser. But how about 3D content, which at least some people might want to use? And that's where our technology comes into the game, because that's where we concentrate on, and that's just a pure, let's say, a setting for this presentation. If I talk about visualization, I always talk about visualization of 3D content and in a web environment. So with our technology, we are able to describe 3D content in a web page in a declarative manner, because of course you could also use just WebGL, but there you would need quite low-level knowledge about how actually to use this content and how to access it. And we can actually embed the 3D content into an HTML5 web page that you can describe things like, let's say that if you click on some object in the 3D scene, then a specific thing should happen. Possibly it should change the color or stuff like that. And we want to do this in a manner that basically every web developer out there is able to deal with 3D content, at least in a reasonable manner. So that's the basic idea of XML3D, which is our basic technology to represent 3D content in a web environment. This specific enabler DyVisual now is built on XML3D and Xflow, which is actually allows us to any web pages already purely in a web browser. But then, additionally to this animation by Xflow, we add with the synchronization dynamic visualization of external data sources, and you will see examples later on. And we can synchronize content across multiple clients. And I hope I can show this also in this demo, in a live demo later on. So this is just the basic features of DyVisual. And in our proposal, we actually, the main idea was how to build DyVisual. It's actually, we use the technologies that we basically had. I mean, they were further developed, of course, in the context of other projects, but also in the context of Fitman. And these basic technologies that are mainly now used in my presentation here and in the demos that I will give is the XML 3D technologies, which is the 3D UI, generic enabler of FI-WARE. Then it's data flow processing, which is Xflow, which brings in the dynamic aspects into the web pages, and the synchronization between multiple clients and the synchronization of external data sources with the content that is actually displayed on the web page. So just because it's almost the major component that is used by DyVisual, at least what makes it special, I want to talk a bit more about the details of the synchronization server, which we call FIVES, or is our own implementation of the generic enabler synchronization server. So the basic setting is here that you've got a web server, and of course a browser can connect to this web server, but behind the web server there's FIVES, and two FIVES now as a server, we can have multiple clients as data providers or data consumers that provide data that actually is provided to the web server and then displayed later in the browser for a user to see. And of course, this can be dynamic content, meaning that dynamically new data gets available over time. The synchronization server itself is mainly built of two things. On the one hand, we've got the core of the synchronization server, which is only concentrating purely on synchronizing data. And the data is, let's say, organized into entities, components, and the components have attributes. So we can define entities. The entities can have components as you want to have them. And each of the components can have a set of attributes that you can individually set and, let's say, put values on. Each of these entities and components can then be managed by individual plugins that actually give behaviors to these components, at least in an abstract manner. And of course, this abstract manner might then reside in some visualization in a browser that is connected to the file system. To define this special behavior, we've got a set of plugins that are predefined, like for example for agents, their behavior, but also for other different things that we want to do in a generic manner. But of course, it's not very easy, I'd say, to provide those plugins that they actually meet all application requirements. So if you want to use FIVES in a specific context, you might sometimes, of course, get into a situation that you need to look at the code of these individual plugins and maybe modify them according to your needs. And this is actually the main idea of FIVES, that it provides you some basic functionality, and if you want to use it with an application, you have to provide your own functionality and your own business logic with it and compile it into an application that you can actually run on the web. And you will see it in a minute what I mean with that. So an extended version of this setting is that we not only have FIVES as a component in our department, but we also provide Compass and Atlas, which extends the idea where are used to define, let's say, complex scenes, meaning that you have got an environment and you've got different 3D objects and you want to arrange them to a complex scene, and you would use Compass. and in the back, Atlas, to actually provide those assets, as we called it, for the scene, to actually put them together. So Atlas is hiding in the back, maintaining all the 3D content, and Compass is putting it together, and then you can provide it to Fives to actually display it to the browser. We actually have, in the context of Fitman, two specific enablers, where one of them we call the 3D Web Viewer, which basically is basing on Compass and is meant to define static sceneries of a complex manner, possibly, using Fives for synchronization of views, but that's it. And then DyVisual, which mainly uses Fives, it might get some input from Atlas or Compass, yes, as a scene, and you will see this later on, but it's meant to visualize dynamic changes in these predefined scenes. So it's mainly meant for doing simulation rather than the static description that is done by the 3D Web Viewer. So are there any questions so far? Because that's basically I wanted to say about the basic setting of the DyVisual and its technologies. Any questions about that? No, because then I would like to go to the demos. And here I hope, oops, okay, let's go here, make this smaller. Because this is what I prepared already in the back, and it's about our world tool example. And what I want to show here. Do you see both browser windows on your screen?
Yes.
Stephen, can you help me? Yes, okay.
Looks fine, yeah.
Because that's important. I hope it will work. Because you see that both scenes in both browsers are changed synchronously, and I can hopefully turn the object. And what you see here is a model of a propeller, which is a part of, in the whirlpool case. And what it is displayed is what we call a deviation map, meaning it shows the difference between the CAD model and the 3D scan of the model. So the use case of this might be that two engineers want to discuss about specific aspects of this deviation map, and therefore zoom in at the same time and maybe are connected by audio. And of course I can also use the other window, of course, to turn things. It's not only one way, it's both ways. Both parties can actually interact at the same time, but of course they have to synchronize, meaning we assume that there is an audio connection between the two of them, and they would agree on who is possibly doing the manipulation, because otherwise we would just get jittering, of course. This is only, let's say, showing the pure visualization part in our partner in Karlsruhe of FZI has integrated this part into their application, where they do, let's say, complex event processing, and there they use this visualization in this context to actually visualize the deviation maps. Additionally to this synchronized view, we also want, but that's not yet finished, but I want to already show it now. I show it in the other use case that we already have it running, but we didn't finish it for this use case yet, that we actually want to provide RESTful web services where you can replace the model and of course also replace the deviation map information so that you can dynamically change it. You can already now change the deviation information, and there I just jump on the web, because in this case to get the synchronization I'm using Fives, but I can go to just an open web page. Oh, let's say where you can actually, because we got the allowance that we can show the model on the web. It takes a while to load, so this is exactly the same model. And here I can switch from one deviation map to the next using those pointers by clicking here these triangles at the lower part, and I can even interact with the model, changing the color mapping if I want to do that, which only is an illustration that you can do this kind of things with using color shading of XML 3D. Pointers to that you can find actually on the documentation that I can also show. That's quite recent. It's at the end of the slides. I give the references to this because there's now a GitHub repository where you can download the codes for the 2 use cases, where I only explained the Whirlpool use case so far, and there you can have a look at the code and also get some other pointers that might be missing in this presentation. So this was just a prepared example. So for now, I can actually I close this down and go here. And just kill files again, which was running in the back. I even can show how I start and stop, of course, the web server. We still have time, yes, of course, still 10 minutes to go. So I shut down the web server first, so it goes down, disappears, and start it up again. This is nothing special, that's just Tomcat, as you can download. Oops, now it crashed. Didn't stop, sorry, for whatever reason, so I try again. Luckily this time it works. I don't know why it doesn't finish the last time. I hope that this don't mean that I spoiled things here. Live demos are always a bit, let's say, exciting. So I go now to the Whirlpool case, and I just switch to my slides briefly. Oops. Because that's the Whirlpool case that I just explained, and I just want to explain the basic setting of the TOW use case. So the idea is that a worker is doing his or her work in a work environment and is tracked by a motion capturing system, in this case a Kinect system. This tracking data is analyzed by complex event processing, where the complex event processing detects possibly some problems in the motions the worker is doing, and this the result of this ergonomic analysis should be presented to a user. And there was already a system developed by another partner who could actually display the results of the ergonomic analysis in a color scheme in a 2D environment, and our idea was to add to that actually an avatar that can actually display the poses that are meant. So how the actual what was the movement the worker actually did, and mark the joint that is problematic with a color scheme that is used by the 2D application. So now let me switch to the demo that I can do on that, which is of course only doing, let's say, it doesn't use really the data that is coming from the CEP, but just from some invented data, of course, that I'm using, because I mainly want to use to show the visualization, how it's done, and how I can interact with the visualization. So I start fives, and it asks for administrator privileges, but only if you compile it with Visual Studio on your own. So now Fives is running. There should be the web server is running too in the back. And now I can go to the web browser, hopefully, and I should be able to use localhost or this one should be the right one. I have to sign in. And first of all, I get here an empty page, so nothing is in there, or an empty scene with just one square where I can put things. And this is just because, oops. So here I started just a web interface that you can download. It's explained in the README files of the code, how you can access that, and you will have it. If you download the code, you have this available, but it only shows, of course, how the visualization can be accessed from the outside, because that's the advantage, because we also have a user interface, of course, on the web page. But that's not nothing that we consider special. We consider the RESTful service interface that we provide to the outside as the aspects of DyVisual that are interesting. So we first create an entity. We send this request, and hopefully, whoops, where am I? TOW should be here. And we see an avatar that appear, and we could put another avatar, but I don't want to make it too complicated. We put it into the initial pose, so it hopefully has turned around. We can use a service that we use a nicer joint, for example, the hips. You have to take a look at the BBH file to see the skeleton, to know what joints are available. But of course, you can do this for all joints that are available for the avatar. And of course, you can choose the color and the size as you want to have it. And then, additionally, you can put the avatar into a specific pose where you can define or specify different joints that you want to set, and for these joints you can set values, and the avatar will hopefully go into this position. Now it leaned back and put the elbow into a rectangular position, and so the REST interface, how we actually can put visualized poses for the TOW use case. But additionally to that, I just delete the markers again, just to make it look nicer. Go to the init position, and then start an animation of a BVH file, which is basically showing a motion for the avatar, and that's the generic part that actually was developed. Oops, it's running out of the window. That's the generic part that we have a BVH player that is able to let's say, play captured motions in a BVH format. However, the problem here is that this BVH format is dedicated to the avatar that we are using, and unfortunately there is a royalty problem with that, so we don't have the license to give away the avatar model on the web, and therefore we unfortunately for now cannot provide the complete implementation that we have, but I'll come back later to this. So I can stop that. So these were the two application scenarios that we have for the Fitman use case. But now I would like to show two brief videos, because just, let's say, having an avatar running around in an empty space is not very exciting. So in the context of another EC project, we actually are working on a scenario like this, where we've got a more complex scene. It's a shelf. The avatar walks to the scene, it picks an object, and turns around and goes to another place, to the trolley, and puts the object on the trolley. Of course, if you want to do that, you not only have to, of course, compute the motions that you want to have in here, so the animations, but you also need to enhance the scene that actually the actions of picking and placing will actually take place. So DyVisual, unfortunately, does not give you that for free. The only thing is that you can do it with it, meaning you can implement it on your own. In this case, because you need to make your scene able to do this picking and placing of objects in a specific manner. So, of course, this is quite a bit of work, but it's less work than if you would want to build such an application without DyVisual, without the help of DyVisual. The other video that I can show is, let's go here. Is actually dealing with the problem that we only, for now, in Fitman use the avatar that has this issues, this IPR issue. And this avatar you can see on the screen here was designed on our own. And what we plan to do is to integrate it with the Fitman applications. What you see here, actually, the Kinect is tracking the human movements, and they are transformed to the avatar, which is moving in a web browser and is just using the 5 and the XML 3D technology. So now I can go back to my presentation. Because this is actually, so here, there was the idea of using the avatar to visualize the poses. And this brings me to the end of my presentation. I'm not sure about the time. How much time did we use? Yes, almost done. So the conclusion is that DyVisual is in our opinion, a powerful tool for dynamic visualization of 3D content in a web environment. We've got the prototype implementations for the TOW use case and Whirlpool. And for the finalization of the work, actually, unfortunately, I should have had the also to give this, because we also, of course, define the roadmap of how to further develop DyVisual in the next time, but I didn't. So I didn't want to commit into, let's say, the very concrete times that we will use for the specific extensions that we want to have. I only had a perspective till, let's say, the review, which is due in November. And till then, I hope that we can finalize the REST interface for the Whirlpool use case and integrate the royalty-free avatar into the W use case, which would be also, at least, let's say, in our opinion, an achievement for this application, because we could provide it completely. Of course, further development is also possible, especially if you saw the integration with the Kinect system, because there you could definitely significantly enhance the TOW use case by using direct, let's say, real-time input from Kinect systems to actually analyze the poses of a worker and display the ergonomic evaluation in, let's say, a real-time environment. So that's, from my point of view, the end. At the last slide gives you a list of links where you also have the link to the GitHub repository, where you can find the documentation, user manuals, and installation guides if you're interested in using the technology and possibly building your own applications with it.